So here is the next bit of our rules of indices, so rule 4. Now on this one, it states when I have two or more things inside a bracket with a power on the outside, that power is going to affect each thing individually. So looking at our first example here, I've got 3b all to the power of 2. So that squared is going to come to each thing like so. But then make sure when you've got a number, you do follow through with that power. So 3 squared is 9. So I'm going to have 9b squared. Next one here, so that power of 4 is going to affect each thing in the bracket individually. So I'm going to have 2 to the power of 4 and x to the power of 4. 2 to the power of 4, if need be, you can always write down at the bottom, work your way through. So 2 times 2, that's 4. Times it by 2 again, that's 8. Times it by 2 again, that gives me 16. Okay. So this next one then, I'm going to have 10 to the power of 3 and m to the power of... Now here, our m already has a power. And we need to remember, we need to recall our previous rule here. So our previous rule was when I have something with a power inside the bracket, with a power on the outside, we multiply the powers together. So for my m in this question 3, I got to multiply m's power with the power that's on the outside. So 10 cubed, so 10 times 10, that is 100, times it by 10 again, that is 1,000. That'll be m to the power of 9. Last one then, so here I've got 3 things inside, but it works in the exact same way. So that power is going to affect each thing individually. So first on my t, the power for 5, it's got a power of 5 and I multiply it by 4. R had a power of 3 and I multiply it by 4. And Q didn't have a power. And then doing those multiplications, I'm going to have t to the power 20, r to the power 12, and then q to the power 4. Okay, so let's look at this with a combination of rules then. So here, I've got my first example here, and I've got a multiplication going on there. So I know that is going to be my rule 1, where again, if I write it out, a to the power of m times a to the power of n, I just add the powers together. So firstly, looking at my numbers, I've got 3 times 2, which is 6. Then I've got x to the power of 4 times x to the power of 8. So adding those powers together, I've got 4 and 8, which is going to be 12. And now I can apply my rule 4 here. So that 2 is going to affect each thing individually. And in fact, it's going to be a mix of rule 4 and rule 3 on this step. So, sorry, let me just rub that. So I'm going to have 6 to the power of 2. So that's here's my rule 4 with that 2 affecting everything. And then I'm going to have 12 times the 2. Then neatening it up, 6 squared is 36. And then 12 times 2 is 24. Okay, next one over here then. So I've got a fraction, but right now I can't do anything with this fraction line until this top bit is sorted out, until it's a little bit easier to work with. So first, I want to do my mix of rule 4 and rule 3. So that cubed is going to affect each thing individually. So I'm going to have 2 cubed and b to the power of 2 times 3. And so neatening that up, 2 cubed. So 2 times 2 is 4, times that by 2 again, that's 8. b to the power 6. And now I can start trying to neaten this up. So I'm going to use just the... So I can use my rule 2 here, where if I used the rule 2, I would look at this 6 and the 4. There's no number to go with that 8 at the front, so that 8's just going to be left alone. And my rule 2, remember, when we are dividing, we take away the powers. So if I did it in that way, I'm going to put 8 and then 6, take away 4 is 2, so it'll be b squared. Or I can do it that longer way, where I write out b 6 times. Write out b 4 times on the bottom. And cancel out the pairs. And then write whatever's left. So on the left I've got 8b to the power 2. There's nothing on the bottom, so it's a 1. But I don't need that 1, so I rewrite it without it. But that's purely because it's on the bottom. Because 8b squared divided by 1 is still 8b squared. Right, let me know if there are any issues, and good luck with the work.